2021 great start info section. So I'm going to talk a lot about the Formula SAE series that we compete in, our team specifically, why you should apply, and sort of our recruitment process. And then I'll give some tips on applying, as well as our team member expectations. And then once I quit yapping, our sub-team leads will go in and talk about the specific projects that are happening this year on each sub-team. And then once that's all done, stick around for the end and we'll have sort of a meet and greet similar to what we did yesterday with Imagine Day. All right, so Formula SAE is one of the largest collegiate design series in the world. There's over 500 schools internationally with 50 countries, and there's 7 official competitions worldwide. So we compete in Formula SAE Michigan, which is obviously in Detroit, Michigan, against 120 other teams. These teams come from all over the world. There's teams from Austria and Korea and Japan, you name it. And it's the most competitive competition in North America. There's also one in California, which we may plan on attending this year. So competition has both static and dynamic elements. So the static elements are business presentations. So this is, you get a business prompt and you have to create a whole business plan that includes your logistics and production of your vehicle, and you have to present this to a group of investors, and you get scored on that presentation. The second is the cost in manufacturing. So we have to cost out every single component and the labor required to make our car. Then we have our design event. So we have to bring all of the information that we use to build our car and justify all of our decision to a group of industry judges. And then for our dynamic events, we have acceleration. This is a 75-meter sprint. Then we have a skid pad, which is a cornering, steady state cornering, like a figure 8. And then autocross. This is like a time attack, usually under a minute. And then endurance, which is a 22 kilometers race split between 2 drivers. And this tests the vehicle's reliability and performance. And this is worth the most amount of points in the competition. And coupled with that endurance race is a fuel economy event. So they measure how much fuel we use for the entire endurance event and give us a score based on that. So to be successful in this competition, there's a lot of multidisciplinary factors that go into this. So we need a lot of knowledge in racing and engineering. We need good design of the car. We need strong project management, strong performance in all of the events. And a bunch of engineering and team-related development. So we have to build a strong team in order to compete well. So a quick summary of last year. Because of the whole COVID situation, it was all online. And so we only ended up doing the static events. But we actually won our design room last year, and we're on track this year, given the performance in previous years, to finish top 15. And I'll talk a little bit more about what the whole situation looks like this year specifically at the end of this. So now a little bit more about our team. So Formula UBC was formed in 1991. We've built 24 cars to date, and we're currently working on our 25th. We're about halfway through that. There's typically about 50 members every year, and this is split between 10 sub-teams. So you can see along the bottom there is all of our sub-teams. And they'll all, each lead will talk about the different projects in a bit here. And we need to, so there's two main aspects of this team, the 2 goals of this team. We want to perform well at competition. That's the primary objective. And we also want to build world-class engineers. So this is an education institution. We want to make sure that the engineers coming out of UBC are some of the best in the world. And those 2 things go hand in hand. So you can't do well at competition without being a group of good engineers, and you can't be a good group of engineers without doing well at competition. So now a little more specifics about our recruitment process. Why should you apply to Formula UBC? We have an incredibly large alumni base, team history, and strong industry connections. We have alumni that work at lots of companies worldwide. This includes Tesla, GM, Ford, some F1 teams, IndyCar teams, and the list goes on from there. we have a really short design cycle and aggressive timeline. So we build a vehicle every single year, and that starts from nothing with a chassis in September, and then in May we compete. In the team's 27-year history, we've been built 24 cars so far, and we've competed steadily for the last 8 years. Last year accepted, obviously. So we have a lot of experience with fairly sophisticated design tools and advanced engineering topics. So this is stuff like FEA, composites, topology optimization, computational fluid dynamics, vehicle dynamics, and tire modeling, engine simulations. The list goes on from there. We also have specific sponsorships and partners with software packages. So we work with SolidWorks a lot, Altium, and you name it, we probably worked with it. The manufacturing experience you get on this team is huge. We work with a whole bunch of composite manufacturing. This includes wet, infusion, prepreg, and most teams at UBC do composites, but most of them actually work exclusively with infusion. So we work with a number of different processes there to make the best car that we can. We also do a lot of CNC parts. So this is stuff that we get sponsored by industry sponsors, and you have to design and make drawings and stuff. Yeah, and then the last item is that Formula SAE is actually recognized worldwide. Pretty much everywhere that there is engineers, there's also Formula SAE, or it's sometimes called Formula Student. So if you apply to a job somewhere, chances are they've heard of Formula UBC. So here's a few important dates. The most important ones are that you need to get your applications in by the 13th at midnight. And then actually it's not on this slide. Oh, it is right at the end there. September 18th at midnight will be when all the final decisions go out. And we're doing rolling interviews up until that date. So a few things that we look for. We look for very driven and dedicated people. We want people that are chomping at the bit and bugging their team leads and just pounding projects out as fast as they are physically able to. We want you to be self-motivated and able to learn on your own. That's huge. We're not going to be hounding you to get your projects done. We expect you to be committed. A few minimum expectations. So we usually say it's about equivalent to taking an extra class. There's roughly 10 hours per week, and that includes our Saturday weekly meetings. And we also expect you to learn along the way. You can't just come into this with everything that you already know and do well. You're going to learn a lot, even if you have some experience. And if you don't have experience, that's great. So here's a few things to include on your application. Talk a lot about your past experiences. You want to sell yourself. You're applying. It's like you're selling a product, but you're selling yourself. No one should have an empty box where it says, tell us about previous projects that you've worked on. You should all have that filled out. And there, you can talk about anything. You can talk about a table you built, or you can talk about a car you worked on is great, but it doesn't have to be automotive related. And then be specific as possible. So tell us which software you've worked with. Tell us like what you did exactly. How did you go? What was the process that you took to go through and solve the problem? And then talk about what you want to learn about a team and what you want to get out of the experience when you select which sub team you want to join. All right, so I'm going to quit yapping now, and Cam is going to talk about some aerodynamics.
Before Cam continues on, I just want to remind everyone to open up our slides if you haven't already.
That's a good call.
Which are in the info channel.
Yeah, so you're good to go, Cam, now.
Right, thanks. So as Graham said, I'm Cam. I'm the aero guy. So basically in Formula SAE dynamic events, one of the biggest limiting factors for our performance is our maximum lateral acceleration. We also have limitations such as the drag produced by the vehicle and airflow to coolant. So the aerodynamic sub-team's purpose is really to manage airflow for all of those purposes, to maximize downforce, hopefully minimize drag, and also to manage airflow to the coolant systems. So the aerodynamics sub-team is currently responsible for the design, testing, and manufacturing of all of the aerodynamic bodies, which includes the front wing, the rear wing. You see these in the presentation slide right now. Side pod, which is a part that helps duct into the radiator, as well as recent additions such as the underbody and this side and rear diffusers. Given the current situation with COVID-19, we're currently going to be working a little bit more remotely and a little bit more computer-based, but we are still actively manufacturing the current or the 2020 vehicle as much as we can. Additional projects are going to include high-performance computing as part of a push to kind of make CFD, computational fluid dynamics, more accessible to more members of the team. We're experimenting with different composites manufacturing techniques to lightweight components of the car, as well as to make the manufacturing process more efficient for composites. And finally, we're making a large push towards physical testing. And that part of that might include things like differential pressure sensing and use of tow tubes, which will be elaborated a little bit by the elect team. So looking forward to see our applications. We're going to pass on to business.
Great, thank you very much. So my name's Liam, and I'm on the business strategy and marketing team in my second year here at Formula UBC. And so the business team is the newest addition to the club and acts as the backbone to many of the team's operations. We have a really diverse set of responsibilities here, and it gives a ton of flexibility and variety for people who want to join the team. In short, our four main responsibilities include social media engagement, sponsorship liaison, team events coordination, and community outreach. And everyone here does a mix of everything, which offers a really good learning experience in our division. And because of our multiple roles and responsibilities, we also work on a ton of different projects each year. And to start, one of the largest things we work on is the business case presentation at the Formula SAE Michigan event. And so here, what happens is we're given a scenario and we have to solve a unique problem and pitch it to a panel of judges. And this is one of the components which goes into us and factors into us eventually, hopefully, placing well and possibly, optimistically in the future, winning the Formula SAE Michigan event. We also do a lot of sponsorship recruiting and retention, which involves possibly meeting with company representatives and reaching out to new firms. And this is one of the most important components of the team, as it acts as the blood of our operations. Something a lot of people don't really know about us is that we're almost entirely self-funded, and that we really rely on going out and getting sponsorship to really fund our events and fund the idea of like new innovations. Next, we also prepare team events, such as guest lectures, unveiling events, and other fun activities. And it's something that's super creative, as we're always looking for new event ideas. Lastly, we also run the social media and marketing side, which involves posting team info to social media platforms and really just networking the team to the rest of UBC and the world to try to recruit new people like all you guys are here today. New to this year, we're looking to hire a social media director and take on more responsibilities on the financial tracking side of the team. And so we particularly want any students with an interest in areas such as marketing, Photoshop, or other creative design to kind of take more of a leadership role in our social media division. It's a role which will give a lot of creative flexibility, and we're really looking to expand this part of our team to really improve our outreach to the rest of the community. And lastly, on the finance side, we're looking to take more of an active role in financial tracking. And so that'll involve things such as reporting budgets, creating financial statements, and doing other general financial roles. So I'll pass it on to Frame and Body, and they can talk a little bit further.
Hi, can you guys hear me?
Yep, you're there.
Perfect. Okay, anyway, so the frame and body team, as you can imagine, is responsible for designing and manufacturing the chassis of the car. Previously, we've run a steel tube frame, as you can see in the top right of the slide. But this year, actually not this year, but for 2 years from now, meaning the competition of 2022. We will be running our first carbon fiber monocoque is the plan. So the huge thing that the frame and body team is focusing on this year is a whole lot of computer-aided design, simulation, a lot of test panel fabrication, and manufacturing process design, working up to our first carbon fiber monocoque car. So that's the difference between a carbon fiber monocoque and a steel tube frame, as you can see on the slide, is that, for example, like a F1 car or a Ferrari or something, a very, very high performance car will usually run a carbon fiber monocoque because they're lighter and they have better mounting freedom and a handful of other advantages which are potentially less obvious. So if you're really into composites, if you like carbon fiber, we're the sub team for you. If you'd like to increase your computer aided design skills, your simulation skills is a big one. We're going to be using Abacus, which is a industry standard software for composite design work. Anything like that, if you like composites, carbon fiber, we're the team for you. We have a few projects left over from last year, but the monocoque is going to be the big project for the next year and the next 2 years actually. So it's going to be a two year cycle for this project.
Okay, hi guys. I am the brakes and driver controls, or brakes and cockpit lead. Our job on the team is we design the systems that the driver interacts with. So that includes the steering wheel, the pedal box, the brake system, the seat, the clutch system. Basically, if the driver touches it or it's used to control the car, that's in our wheelhouse. We're going to be working on a huge number of projects this year, including a brake dyno, which basically allows us to test our braking system, including a bunch of materials testing. So we're going to be working closely with the materials team on that. We're improving our pneumatic clutch, which is going to involve electronics tuning and pneumatic systems, as well as mechanical design. A new pedal box, which is going to be closely integrated with the electrical team, as well as being heavily mechanical design. We're doing a new seat, which is very much working with humans and human bodies, and working to design a mechanical or a system around the human body. And then we have the steering wheel, which is going to be hopefully a very complex mechatronic style project that's going to include custom PCBs, buttons, carbon fiber manufacturing, a whole range of disciplines within that one project. So as you might be able to tell, we're a very wide-ranging sub-team. We take on projects that interact with everybody across the team, because everyone other sub-team they go through the driver. So we interact with everyone and do a little bit of everything. So let's go to electrical. Yeah.
So my name's Sean, and I am one of the co-leads for the electrical team this year. The electrical team is responsible for ensuring that electrical power gets to where it needs to be when it needs to be there. We do this utilizing custom-designed solid-state switching circuits and custom microcontroller firmware. This power is crucial for running our engine, as well for powering vehicle actuation systems such as shifting, as well as making sure cooling is working. As well, we are responsible for maintaining a wide range of sensors on the car, including pressure sensors, temperature sensors, and load cells. Lastly, we ensure that this data is collected and allows other sub-teams to validate and improve their designs throughout the year and for future years. And up next, Aiden, my other co-lead, will talk to you about the projects that electrical team has coming up this year.
Yeah. Hey, guys. So if you come to the electrical team, you can expect to work on a wide range of projects that span all sorts of fields within electrical engineering. The first and primary role and responsibility of the electrical team is the distribution of power. So we do this through projects like our power distribution module, which you can see in the picture in the top right of the slide, as well as this complex harness, which you can imagine has many different signals distributing power to all parts of the car. The other things you can expect to work on are different sensor and data processing projects. So that's varies from things like pitot tubes that Cam mentioned earlier, which measure the airflow over different aerodynamic surfaces, to suspension travel and strain rosettes on all of the A-arms of our car. So lots of different sensor and signal processing projects that we're looking to get into. Other projects you can expect to participate in as a more experienced member, if you're in especially second and third or fourth year electrical engineering, is more complex controls projects. So one example of our previous project would be our closed loop shifting board. So that's a very complex controls problem that we're looking for more experienced members to tackle. So overall, we're looking for people who are passionate and willing to learn, but also more experienced electrical engineers to pursue more complex controls problems. So I'll pass it on to POWERTRAIN now.
Hello, everyone. So this is John. I'm the new POWERTRAIN sub-team lead this year. And the powertrain sub-team is a new sub-team this year. We combined the engine and the drivetrain sub-teams since these sub-teams work really closely together all the time. And as the name suggests, the powertrain sub-team is responsible for power delivery of the race cars. So this is literally the sub-team that turns the wheels and makes the car go. So the powertrain sub-team mainly is responsible for the engine or the power unit and all the peripherals and development of these peripherals. So we're also responsible for dyno and on-track tuning of the internal combustion engine. We do a lot of mechanical and thermal design, mainly the thermal part being the dry sump oil system and the cooling system. And most importantly, we ensure the drivability and the efficiency of the car is top-notch at all times. And some projects we are working on and will be working on this year are the oil system, and the cooling system. These are some previous projects that we weren't able to finish due to COVID. The fuel supply and the exhaust system are obviously one of the projects we'll be working on. Some cool projects that are new this year will be the drive-by-wire and clutch actuators, which will be working closely with the electrical sub-team and the control sub-team. The brakes and cockpit sub-team. And as you can guys see in the slides, we're also in charge of the differential and the CV joints of the power delivery system. So basically, anything that's related to the engine and the safe running of the engine will be under powertrain sub-team. And the topics of the sub-team might kind of give the hint that this is one of the more advanced sub-team, but this is not correct. Even if you don't have experience with, I don't know, cars or engines specifically, if you have experience in thermal design or thermodynamics and stuff, that would be also valuable in the sub-team. But yeah, I'm looking forward to seeing your applications, and we'll move on to materials.
Hi everyone, I'm Freya. I'm the materials sub-team lead. The materials sub-team is quite different from all of the other sub-teams. It gives individuals the opportunity to work on work with a variety of sub-teams to support their project goals. Because of this wide range of project opportunities, I find that you get a better overall understanding of all of the vehicle systems instead of just one. Our role on the team is not only material selection and mechanical testing of components, but we also work on design and simulating components. We also have a really large role in composite manufacturing of the team. So as well as like frame and body, we work really, we will be working really closely on the monocoque design, but we've also helped with almost all of the other sub-teams if they're using any sort of composite. So some of the projects that we'll be working on this year, one of the first one's a continuation. We'll be working on the brake system dyno testing. So previously we've had some brake overheating problems. And so by creating our own dyno, we're going to quantify that and be able to analyze that more. The second one would be obviously a large project, the monocoque material selection and manufacturing support. The other one would be steering wheel redesign, so helping with controls and electrical on that one. Investigating alternative manufacturing methods for airfoils, so that'd be working with AERODYNAMICS, and looking into affordable high temperature prototyping materials, so being able to 3D print materials that could be used closer to the engine is something that we're interested in. I believe next is software.
Yeah, all right. So hey, I'm Huntington. I'm actually not on software. I'm on ELEC, but I'm here to kind of give you guys a brief blurb while our other lead isn't here. So software is another kind of supporting role kind of sub-team, but a lot of what they do is really important for driving the design of our current cars. So an example of what you'd be doing on software is creating types of simulation software. So one big example of that is our lap time simulator. We're able to put a bunch of parameters into this, and it will kind of give you a simulated track performance. And by kind of moving these parameters around, we're able to kind of make decisions about how we want our car to be before we even start doing any hard design. So very important for kind of setting up the beginning of the year. But they do other things. So from the electrical perspective, software is able to aid in making firmware for all of our embedded systems. That's a little bit different from developing things like the desktop applications such as the lap time simulator. And just in general, they're kind of it's a team that's there to support the other sub teams. So a sub team may think that they would like some way to simulate some certain physics related to, say, brakes, and the software team will look into a way to do that, whether it's through a language like C or a scripting language like Python or MATLAB. So it's one of those teams where we're looking to expand, and I think there are a lot of projects that can be had, especially in a time like now. And yeah, pass it off to suspension. Watch tech.
Hey, I'm Wojtek. I'm the suspension team lead this year. Out of all the sub-teams on Formula, suspension definitely has the most impact on how the car handles. We're in charge of the tires, the wheel assemblies, the A-arms, damping, as well as steering, all of which have an impact on how the car steers and handles on track. During a typical year, we start off with some modeling. We look at tires, kinematic, and vehicle dynamics. With those simulations, we can determine what we want our suspension geometry to be and what our hard points will be for the year. Once we have that locked in, we look at the mechanical design. We actually design all our parts in CAD and then manufacture them. Once that's done, we take the finished car on the track and use a multitude of sensors to compare how well the manufactured car compares to our design targets. This year, some of the projects we're going to be looking at is the rear shock repackaging. We're not super happy with how it works at the moment. We're going to redesign the front and rear anti-roll bars. We're going to do some more kinematic simulation, and we actually have a really cool project where we're looking at flexure carbon fiber A-arms. So if you would like to apply to suspension, I'm looking forward to your applications.
I think it's back to Graham.
All right, thanks everyone. So a lot of people have been asking, and this is a totally valid question, of what the heck we're going to do now that the world is almost ended. So we've heard from competition a little bit. It's sort of a tentative update from them, but competition is still going ahead. We're going to be having all of the the static events will be virtually with like a WebEx webinar type thing, similar to what we did last year. And then they're planning on still having in-person dynamic events. Exactly what that might look like, we're not sure yet, but we'll keep everyone posted as we get the information. In terms of our team specifically, we're still working somewhat as normal. We're operating under the assumption that competition will still be happening. We're working every Saturday virtually. We're meeting on either Zoom or Discord. We've taken a few small parts home, so our bodywork and some aerodynamic components, as well as like throttle bodies and stuff like that can be worked on at home or in a garage somewhere, we've taken out of the shop. And then we're still working with the faculty to figure out exactly what a return to campus might look like, or if it's possible in the near future. But eventually we will have to build a race car, and we can't do that from the comfort of our living room. So eventually we will be moving back into the shop. And when that happens, I'd like to say that if you're a new member, you can expect to be invited into the shop if you're in Vancouver, because I think that that's such an important aspect of the team, is working on the car physically. So you won't be left out of that part. If you're not in Vancouver, you should still, I would still encourage you to apply to the team, because we're going to be making accommodations with the projects that we're giving to people that are not necessarily in Vancouver. So you can work remotely on stuff in your own home. And then all of our meetings will be either recorded or with meeting minutes. So if you can't attend because of time zone issues, it's possible that you can still be up to date with the team. And finally, I have some closing remarks. So first, consider your motivations when you're joining this team. Formula SAE is a very prestigious competition, and we take a lot of pride in competing at a very high level. So we're all in this for more than just a line on our resume. We're all here because we care about the team and we want to see it succeed. It might seem a little bit silly to invest so much effort in just a student team, but we wouldn't be here if there was no reward. The level of effort that you put into pursuing your passion will directly correlate to the quality of your work, and hence how much you get out of it. This picture on the left is a screenshot from a video of the first time our engine ran this year. This is actually of Huntington. This is after 2 all-nighters back in March trying to get the thing running. Unfortunately, I can't play the video for you because there's a few words in there that aren't exactly appropriate for a public setting. But I hope this just shows how much that we care about the car. The second thing is that, unfortunately, this is not a party crew or social club. So typically the closest we get to that is having a beer after a long day work together. We go to the bar and stuff, but we are in this to work. The day-to-day work may look an awful lot like a full-time job or a part-time job, but as you see, the people on this team and the bond that we build through this process is very real. We're a family and we can look out for each other. The ups and downs from both the school and Formula project bring us all together. And finally, just some general advice. This can be for either applying to the team or just in your university career. Take on some big challenges and challenge yourself. We're meant to struggle. For some of you that are just entering engineering, maybe in first year or even second year, it's going to be hard. It's a lot of work, and it might seem like you chose incorrectly at times, and you just need to keep pushing through it. A project like this might seem really impossible to accommodate into your schedule, but when you look back at the experience and the education and the connections that you gain through something like this, there's nowhere else you're going to get that in university, and it's well worth the effort. And the last thing, which is a little cheesy, but the universe really does reward hustle. If you work your butt off, you're going to get somewhere.